We have been learning about this topic of measurement here, right? And now we're up to something called volume and capacity. Have we seen that before, those words? Yeah, we have. Does someone want to have a go? What is volume? What is volume? Go, Momo.
Volume is like the centimeters cubed.
Volume is like the centimeters cubed. Do we agree, guys? Yeah?
No.
No, you don't agree. Mannix, what do you think?
I think volume is not like centimeters cubed. It is centimeters cubed.
Oh, okay. So the revision is just one little word that's different. Now can I just say, you guys aren't wrong in some sense. Volume is not that, but that is one way we used to measure volume, cubic centimeters. That is one way we can measure volume. But that's not quite the definition there. Ollie.
Volume is the amount of space an object takes up, and capacity is how much liquid it can.
Oh, interesting. Did anyone have something similar? So Ollie said that volume is the amount of space something takes up, and capacity is the...
How much it can hold.
Okay, so for example, let's do an example. This here, let's say this is about let's just say hypothetically this is 1 cubic centimeter. I've just chosen this one, right? What's the capacity of this object? 1 milliliter.
No, that's like 50.
So what did you say capacity again was?
How much an object can hold.
So how much can this hold?
0 milliliters because it's not hollow.
Oh. Interesting questions. I really like that definition. Can you write that down for me? Volume is the amount of space something takes up, or an object. And then what was the definition of capacity? Well, capacity is slightly different, right? If volume is the amount of space something takes up, capacity is how much it can, Isaac? Yeah, how much can it hold? How much can an object hold? Now, we've already got some measurement of volume. For example, cubic centimeters, we can have cubic meters, and there's cubic millimeters even. When we're talking about how much can an object hold, we use some slightly different kind of units. What do we use, Liz?
Millimeters, liters, kilometers.
Yeah, liters. So you said millimeters. Is that the one? Milliliters. Milliliters. Milliliter. Kiloliters, if you're talking about like really big masses. Yeah? Right, okay. That's right. So, now, that's the difference between volume and capacity. We're going to look at how to actually find volumes of particular shapes now. Let me give you an example, right? We took our blocks here, right? If I take one of these, let's say this is 1 cubic centimeter, right? So we're looking at the volume. So find the volume of... So if I take this one block here, right? How do I know that it's 1 cubic centimeter? Well, if I take this block, all these side lengths here, they're all 1 centimeter. They're all 1 centimeter. So when I'm thinking about the volume of something, all I need to do is I need to multiply all of these lengths together, and that's what helps me find what is going to be the volume, right? So the volume would be, so V for short, 1 times 1 times 1 times 1. And what's that going to be? That's just 1.
1 centimeters cubed.
Yeah, and you can see why they have the 3 there now, because you're literally multiplying 1 by itself 3 times, right? What if I change it now? What if I have a different shape? What if I have this one?
Still a square, so.
What's the volume of this shape now? How much space does it take up?
4
Go with some ideas. Jesse, sorry.
So each of them are 2 centimeters, so you do 2 times 2
Yeah.
times 2, which is
Okay.
8.
So let's
8 centimeters.
So you're saying 8. Let's just draw it up to be short, right? So this is example 1. This is example 2 now. So because I know that each of these lengths is 1, right? Then obviously that length there is 2. We've got 2, and we've got 2. The volume, again, all we're doing, year 8, all we're doing is we're multiplying these all together, and then we're calculating that. We know that's going to be, 8 cubic centimeters. Now, what's another way you could have gotten that? Well, we could have just counted the number of blocks you can see, right? And you can see very clearly there's 8 blocks here. There's 4 on the bottom, 4 on the top. Can you see that? Yeah. 4 on the bottom, 4 on the top. Can you see that? If you kind of break it up. Yeah, then you can see that. What about this one now?
Ooh, Rubik's
It's a Rubik's Cube. How many blocks are there on this one? That's the same thing as the volume, right? How many blocks are there here? 27. 27. Now, we can't see all of them here because some of them are kind of hidden, right? But I hope you can start to see that volume can be found similar to area where just by counting a certain number of things, right? If you just count the number of blocks there, you can find the volume. Does that make sense, right? You don't always have to do that, though. It's much easier sometimes once you have that understanding to just simply multiply all those lengths together. Because I know that all of these lengths, because we've got a cube here, all of these lengths, they're just going to be 3. And then I can find the volume very easily by multiplying them all together. 3 cubed, yeah. 3 cubed would be 27 cubic centimeters. Right? Let's take a more complex shape. What about something like this? What have I got here? I've got a cornflakes box. What shape would this be, do you think? I think I heard it. Yeah, rectangular. Yeah, so thinking about a prism, right? This is a rectangular prism because you can see on the face you've got a rectangle. And the reason why it's called a prism is because it's the same shape throughout the whole thing. If you look inside, I've got some stuff in here, I want to take it out. If you look inside, you can see a rectangle throughout the whole thing. Can you see that, Yure? Yeah? That's why we call it a prism. Okay? So let's draw this prism out. Let's draw this prism out. And I'm going to give you some measurements. If we were to do it in a similar way, so this is our cornflakes box here, we should make that really clear. Cornflakes. What was the first way to introduce finding volume? What did we do? We kind of like counted up the blocks, right?
Yeah.
If we were to do that with this one, could we do that? Yeah? Yeah? Yeah, if we had the right blocks, we could, but it would also kind of take a while, right? What's a better way we can do this? What's a better way we can do it? Mia? Yeah. Yeah, okay, so rather than doing that now, rather than just kind of counting up the blocks, we don't have to really do that anymore. We can just actually multiply these all together. And that's the formula for today, right? The volume of any prism, sorry, the volume of a, actually not just any prism, sorry, I should rephrase. The volume of a cube or a rectangular prism, so this is only for a cube or a rectangular prism, we can do that by multiplying the lengths times the breadth times the height, which is what you're doing here. The length times the breadth times the height. Question, son?
Shouldn't that side be the 30 and not?
Oh, yeah, probably should, hey. Can you guys change that for me?
That's what I automatically changed. Wow.
Good job. Thank you, Jackson. Someone got an answer. Hands up. Hands up in the air. Who's got an answer? Edgar. Okay, so when you calculate this now, year 8, I also want to see that full working out. So we've got the volume is equal to, so we've got the length times the breadth times the height, and that's exactly what I'm going to do here. I'm going to do, as Edgar said, 20 times 7 times 30. And what did you say that was again? Sorry? What was the answer for that one when you multiplied all this?
I think I would know.
Okay, 4,200 cubic centimeters. Did we all get that? Yeah.